Hi algebra students, this lesson is going to be on linear applications. When I say applications, what I mean is applying all the stuff we've learned about linear equations to real life and real world situations. So that objective is going to say exactly that, is we can use these linear equations for real world problems. Now, as we've been going through these lessons, I've included a couple examples of real world problems in each lesson before this one, just to get you a little familiar with what it can look like. But this lesson is going to solely be focusing just on real world situations. All of the math is going to relate back to what we learned in the first 4 lessons. So if you are watching this and don't know what I'm talking about when I say linear equations or slope or point slope form, any of those words, those were all things we talked about in the first 4 lessons in this unit, in Unit 2. Make sure you've watched those videos first before watching this one, just because all the math stuff we talked about in those we're going to be using today. The first example we are going to look at is this one right here. We are given a table over here. Before I say anything else, I'm just going to ask you what you notice about this table here. Nothing is too silly to say. Feel free to include multiple observations if you want, but this is something I start off class with, is give students this table and ask, what do you guys see? Go ahead and answer that question now. All right, so in the past, some of the things I've heard is, well, I see it's talking about the number of pizza toppings and the cost of pizza. Great. One of the most important things is making sure you read the labels in your table or in your graph. Some students sometimes point out that the variables are different. At this point, we're used to a lot of our tables saying X and Y, but instead they say T and C, T for toppings, C for cost. Some of the other observations I've gotten in the past is more toppings on the pizza mean it costs more, and that's a great observation. It means as you add in more toppings, the cost is going up. Sometimes when students say that, I prompt them for a little more information, and usually at some point someone in the class notices that if you go up another topping, the cost goes up 50 cents. So every single time you add in a topping, the cost goes up another 50 cents. So I could ask, well, what do you think the cost is for 5 toppings? And you might be able to tell me, well, based on this pattern, the cost is $7.50. And we could keep going, right? The question is asking us to write an equation of a line represented by the table below. I have given you that exact question before. The difference is when I gave you that question, it just said X and Y, and it was just simply points on a graph. But here instead, we've got like real world information. Now, before, when we were writing equations from tables, one of the first things we said you always are going to need to know in order to write an equation was, what did you say? Do you remember? Is slope. No matter what information you're given, you need to know slope to find your equation. So looking at this, I've got a bunch of points, I've got a bunch of data, but I don't know slope yet. When you go to find slope, we're going to use the formula y2 minus y1 over x2 minus x1. When we did this in the, wow, yeah, it was the last lesson. Sorry, time flies by. When we did this in the last lesson, one of the things we had talked through is the fact that you can choose any points you want. You just need 2, and we have 4 here. So you can choose whatever you want, but go ahead and choose 2 points and use it to find the slope for yourself. All right. Now, just like we said before, it does not matter which 2 points you choose, but I will tell you, I have been teaching this lesson many, many times, and usually students like to choose the 2 points that don't have decimals in them. So we could use the 0.26 and the 0.47. It does not mean you did anything wrong if you picked the ones with the decimals. You should get the same answer we do. The math might just look a little different for you. For y2 minus y1, let me add in this extra step of labeling my points. And it makes it a lot easier to make sure you've got your numbers in the right spot. y2 minus y1 would be 7 minus 6. And then x2 minus x1 is 4 minus 2, which gives me 1 over 2, or 1/2. You could go ahead and divide it into a decimal, and if you had used one of the points that had a decimal in it, you would have gotten something like this. But one of the things, remember, we're doing is we're writing an equation, and this is a multiple choice option. So if I'm trying to decide, do I want a fraction or a decimal, I might glance over at my options. I see some of them have fractions in them, so it means it probably is going to be helpful for me to keep it as a fraction and not a decimal. So I'm going to go ahead and say a half. A half is my slope. Just by knowing the slope is a half, a good test taking tip, you can come over here and you can eliminate some options. If you know the slope is a half, look at the 4 equations. Which ones have a slope of a half? A does, B does, C doesn't, and D doesn't. So if that is all you knew how to do, you've got an idea the answer is going to be one of these two. Now we've got our slope is a half. One of the focuses of this lesson, and we talked again a little bit about this before in previous lessons, but one of the main focuses of this lesson is not just being able to do the math, but also know what the math means. What I mean by that is 1/2 represents something in this problem. Yes, it represents the slope, but it also represents something regarding what we're talking about with toppings and pizza. Do you know what a half means? Well, think back to some of the observations we talked through at the beginning when all we had done is looked at the table. One of the observations that usually someone in every class points out is this idea that when you add in toppings, the cost goes up 50 cents. 50 cents is the same thing as half a dollar. So I could put back that decimal again just to show you where it relates. This half, or 50 cents, goes back to the idea that each topping you add makes the cost go up 50 cents. Each topping costs half a dollar. So that slope right there, that half, it does represent slope, but it also represents the cost of one topping. Think back to one of those first questions I said. I said, if we kept the table going, if we put 5 here, the cost is just going to go up half a dollar. The cost is going to go up to $7.50 just because each topping costs half a dollar. That is what our slope represents. We still are not done though, because we still need to write an equation. So step 2 of this problem, at this point, I don't know why I erased it. You know the slope is 1/2, and you know all the information in this table. Go ahead and try getting to an equation of the line. Well, just like we did in yesterday's lesson, you've got a slope, you've got a bunch of points. If you know points and you know slope, you can write an equation using point-slope form, which looks like y minus y1 equals m times x minus x1. If I'm using that formula, I can go ahead and replace my slope with 1/2. X and y are going to stay there. It's just x1 and y1 that I need to substitute. Again, we have got 4 points we can substitute. It does not matter which one you choose. But again, usually students go for one of the ones that don't have decimals in them. So I think I'm going to use this one here. That means my y1 is going to be 6. So I'm going to say minus 6. And then over here, my x1 is 2. So minus 2. Now, just like in yesterday's lesson, we'll go ahead and change this to slope-intercept form. I notice when I'm looking at this equation, it wants an equation. This is an equation, but notice this isn't any of these equations. They all have them in slope-intercept form. So we'll go ahead and change it. I'll do that by distributing my 1/2. 1/2 times x is 1/2 x. And then 1/2 times 2. Remember, you can do 1/2 times 2 over 1 and multiply it out the long way. But if you're multiplying a half by a whole number, it's just half of that number. So 1/2 times 2 is the same thing as half of 2, which is 1. It's closer to slope-intercept form, but it's still not done because we need y all by itself. We want y equals mx plus b. So I can get rid of my minus 6 by doing the opposite and adding 6 to both sides. Negative 6 plus 6 is 0, so that cancels. And we get y equals 1/2 x. Negative 1 plus 6 is a positive 5. And we've got our equation. Now, usually that is enough information for students to know what the correct answer is. If you've got this as your equation, you glance over there. At this point, most people are able to tell me the correct answer is A. I will point out, though, that this is not exactly what they've got there. Do you see what the difference is? Well, we have different variables. It goes back to one of the observations students make a lot when they're looking at the table. Notice it's not talking about x and y anymore. It's talking about t and c. I did all my math using x and y just because that's what the formulas say, that's what we're used to. It's totally fine to do all your math with x and y in it, but when it comes to the end, one of the steps we need to make is changing our variables back to the variables they used. Sometimes it's hard for students to figure out which one should go where. Should it say c equals or t equals? Just think about where these variables are compared to x and y. Normally this first column is x. That means I want to change x to t. And normally the second column is y. So I would change y to c. So that would let me say, okay, instead of y equals, it'll be c equals. Instead of x, it'll be t, which is how I get this equation here. Now we've got the right answer, but I'm not done talking about this problem yet. Remember I said one of the focuses of this lesson is not just to be able to do all the math, although doing all the math is very good, but we also want to know what all this math means, what these numbers mean. We already said what a half means. Do you remember what we said for a half? Well, we had noticed that the cost is going up $0.50 each time you add a topping. Another way to say that is each topping costs $0.50 or each topping costs 50 cents. This number here, though, which is our y-intercept, also represents something. That 5 represents something here in this situation about like toppings and or a cost of pizza. Do you know what the y-intercept 5 represents here? I think the 5 is a little harder to see. What I want to do, though, is think back to what we talked about when we were graphing linear equations. If I asked you to graph this equation, the first thing you would always do is mark your y-intercept. We would go to our y-axis and put a point at 5 because that's where our line begins, and then we would use that slope of 1/2 to find more points on the line. I'm emphasizing it's where the line begins. Looking at this, one of the things when I asked students at the very beginning of this problem for observations, one of the things I've heard on occasion students say is, well, the price of pizza starts at $5.50. And I definitely see where you're getting at if you make that observation from the table, but they're only showing 4 options, and there are more options. You could have 0 toppings on your pizza, would not be a tasty pizza, but 0 is that true starting point, right? And if there is 0 toppings on the pizza, go the opposite way. The cost of the pizza then would be, well, if we're going backwards, we're going down 50 cents. The cost of the pizza would then be $5. That 5 right there represents, you could say, the beginning cost of pizza. You could say the cost of the pizza with 0 toppings on it, the cost of the pizza before you start putting toppings on it, something like that. If I take this equation, one of the things we did a lot with word problems is I would look at my equation and put it back into words. Let's do that for this equation. This is saying the cost of the pizza equals $0.50 per topping plus $5. That's exactly what this table is saying. It's saying the cost of the pizza is $5 plus 50 cents for each topping. And you could keep saying that as you go down and check more and more points there. So to kind of summarize everything we've said at this point, there's a spot for us to write the meaning of these 2 things. We have got the slope, which was 1/2. The slope 1/2 means that the cost of each topping is $0.50. Or some of you at home might have said 50 cents, which is totally fine because half and 50 cents are the same thing. The y-intercept, which in that last problem was 5, we could say represents the starting cost of pizza. You could say something like that. You could say the starting cost of pizza with 0 toppings, with no toppings, anything like that. So to practice all the math we did, but to also practice these two things here, I've got a question for you to look at. I'll go ahead and erase all of this. In this problem here, we've got a kennel in Bloomington offers daily boarding for dogs. The table below has the cost for different intervals. So in the table it says days as n and gives you 3 different pieces of data. And then it shows the total cost t, and it gives you the cost for 3 days, the cost for 8 days, and the cost for 12 days. The first question I have for you is which equation below best represents this functional relationship? Which of these equations goes with this table? Go ahead and try that. Now when you're doing this problem, same as before, the first thing you could do is find the slope. And when you find your slope, you're going to get the slope is 20. You could definitely keep going to write that equation, but once you know the slope is 20, if you come over here and check all of the equations, the only equation that has a slope of 20 is this one here. So we get t equals 20n. Now I'm not done. There is a second question for this. Similarly to what we did in the last problem, I want you to tell me what the slope is and what it represents, and then what the y-intercept is and what it represents. So just like in that last problem, we said the slope is 1/2. It represents each topping costs $0.50, like that. I want you to do that same thing for this equation here. All right, well, I had said a moment ago the slope is 20, but what does 20 represent here? Well, that slope is telling you it's costing $20 each day. It's important for you to say each day or every day, every one day, something like that. You cannot just say the cost is 20 because notice the cost isn't 20. The cost is changing depending on how many days your dog is at the kennel. You have to include that each day part. It costs $20 each day. Now the y-intercept for this equation maybe is a little harder because we don't see it. We had learned in previous lessons that if you don't, if we don't see a number there, that number must be 0 because you don't need to write +0. That y-intercept is 0. Well, what does 0 represent here? Well, similar to before, it is that starting cost. At 0 days, it costs $0. Well, that should make sense, right? If your dog isn't there anytime, it shouldn't cost money. But that's also telling us that there isn't any like initial cost. It's just solely cost per day. They're not adding in like any other extra fees in there. So that $0, we could say it means $0 for 0 days. You could say there's no additional fees. You could say it's like the starting cost at the kennel is $0. Any of those could be possible answers. The next example we're going to look at, instead of looking at a table, these next ones are going to involve graphs. So here, if I'm reading the directions, it says the graph below represents the total number of times a certain website was visited over a 5-day period. Again, just looking at this graph here, what observations can you make? Nothing is too silly to say. Feel free to tell me lots of different things you notice about this graph. Go ahead and try that now. Okay, some of the things I've heard in the past when I've asked this question in class is, I noticed the title is website visits. That is a great place to start when you are looking at a graph. Always read your table title, not table. Always read your title. Always read your X and your Y axis. So usually along with that, students will tell me, I see down here on my X axis that it's showing the number of days. And on this Y axis here, it's showing the number of visits to the website. Some of the other things I've heard is the line's going up. Cool, what does that mean? Well, the line is going up because as more days go by, it gets more visits because, you know, certain people are visiting it every day. All right, what else do you notice? Sometimes students notice, well, down here it's going 1, 2, 3, 4, 5. Over here, it's counting up 20, 40, 60, 80, 100. It's counting up by 20 on this side. One of the reasons they would want to do that is because if you're counting up by 1 over here and you need to get all the way up to 140, 160, that is a very big graph. We are used to coordinate planes, the ones where you're not talking about real world stuff, each square representing 1. But especially when you get into real world situations, sometimes it's just not practical to count up by 1. This would be an example here. If we're trying to get to larger numbers, we might need to use a larger scale. Some of the other things I've also heard students point out is notice here, this graph in general looks different from a lot of the other graphs we've seen. And the reason for that is part of the graph is missing. Notice here that we only have what we call one quadrant, when usually our y-axis and our x-axis keep going there, and we have 1, 2, 3, 4 quadrants. Why do you think parts of our x and y-axis are missing there? Well, what would be there? If I kept going this way, after 0 would be -1, -2, -3. If I kept going down this way, we're counting by 20, so it would be -20, -40. They've taken out the negative numbers. And why would they do that? Well, because this is talking about number of days. You can't have negative days. And this is talking about number of visits. You can't have negative visits. Do you think that's always going to be the case, that the negatives are missing? Well, no. If you're talking about cost, if you're talking about temperature, maybe even height, because you can go below ground in negative, all of those things are things that you can use a negative number to represent. So it doesn't necessarily mean every real world problem doesn't have negatives, but there are definitely a lot of things in our life you can't use a negative number for. So if that is the case, those negative areas of the graph might be missing. I think we've done a good job talking about this graph. The other thing I usually do is just a quick check to make sure we all are good at reading what the graph is saying. Remember, this is showing the number of visits over time. So each of these points is telling you something. It's saying that after day 1, the website has gotten, well, right between 20 and 40 is 30. So after 1 day, the website's gotten 30 visits. After, let's do 4 days, the website has gotten 120 visits. After how many days has the website gotten 90 visits? Well, 90 is right here. So it looks like day 3. Just like a quick check to make sure we know what the graph is saying. I think it's time to finally answer some questions. The first question says, what is the slope of this line segment and what does it represent in terms of the situation? So there are 2 questions here. We want to know what is the slope and we want to know what does it represent. Well, let's start with slope. When we're finding slope of a line of a graph, what would we use? When we're talking about slope with graphs, usually the formula we use with that is going to be rise over run. In order to use rise over run, you need to pick 2 points and then count your rise or how much it goes up and down, and then count your run or how much it goes sideways. I can use any 2 points on that graph. Go ahead and try finding the slope. Okay. When I go to count my rise and my run, notice we don't have lines every spot. I like to pick 2 points that are on the line, that are like clearly marked. So for me, I could use maybe this point here, and let's do this point here. We said we wanted to count our rise and then count our run. When you go to count your rise, I've done this enough times in class, so I know it is very tempting to go 1, 2, 3. but there's something wrong with that. Do you know what's wrong with that? Well, remember, one of the observations we made is that over here they're not counting by 1. So when I'm counting my rise, also not going to count by 1. Over here, notice we're counting by 20. So when I go up a line, I'm not going up 1, I'm going up 20. So when I go to count this, I would say 20, 40, 60. Our rise is 60. You could also just look at your starting number and your ending number. I'm going up from 60 to 120. The difference there is 60. 60 plus 60 gets you to 120. The run's a lot easier because the run is counting by 1. If I'm going from 2 to 4, that is 1, 2. So my run is 2. Rise over run, 60 over 2, which equals 30. That should have been the answer you got no matter which 2 points you pick. You could pick points really far apart. You could pick points really close together. I think these right here also are like another pair that's easy to see. The rise is 30, the run is 1. It can be easy sometimes when they're closer together because you don't have to count as much. We got our slope as 30, but we have not finished answering this question because the second part says, what does it represent? Well, in this problem here, what does 30 represent? I think to help illustrate what 30 represents, let's read a lot of these points. Day 1 is 30 visitors. Day 2 is 60 visitors. Day 3 is 90 visitors. Day 4 is 120 visitors. Do you notice anything about those numbers? Well, each time 30, 60, 90, 120, each time it's going up by 30. That slope of 30 represents that you are getting 30 visitors after 1 day. 30 visitors each day. So what it represents for this situation, we could say the slope is 30, and then we could say the website, what am I writing? I'm sorry, guys. The website, I got all thrown off because I can't spell apparently. The website gets 30 visits. You can say each day, every day, per day, every 1 day. I'm just going to say it gets 30 visits each day. Similarly to those first 2 examples we looked at, you can't just say the website gets 30 visits because the website we can see is getting a lot of visits after time goes by. That each day part is important. This was the first part of the question. There are 2 more parts to the question. The second part says, write an equation that represents the total number of times this website is visited V after D days. Now again, we've written equations from graphs before. We just haven't written equations from graphs that look like this. But in general, when we've written equations from graphs, what linear equation form would we use? What formula did we use? Well, on a graph, there are 2 things that are easy to find. You can find the slope, which we already did, and the other thing we usually looked for was that y-intercept. The formula we're going to use is slope-intercept form, or y equals mx plus b. If I'm using this form for my equation, there's something in that previous question that we've already figured out. That's our slope. I know my slope is 30 from that first part. The only other thing I need to find is my y-intercept. What is the y-intercept of this line? Well, remember this right here, this is your y-axis, and your y-intercept is where your line crosses your y-axis. Your y-intercept is at 0. This right here is where that line begins, at 0. So in our equation, I could say y equals 30x plus 0, but we've seen in a lot of previous problems that plus 0 is something you normally don't see, something you don't need to write, because plus 0 isn't changing anything, right? 0 is nothing, so we can write nothing. So I've got y equals 30x. It's a pretty good looking equation, but that is not the right answer. Do you know why? I'll give you a clue. Read the question again. Well, if I read the question, it says write an equation. I did that. It says write an equation that represents the total number of times this website is visited. Oh, V after D days. My equation is not done because I'm not using the variables they want me to use. Again, we're really familiar with equations, linear equations that use X and Y. That's the way our formulas are written. But if they're talking about real world situations and they're telling you use these variables in your equation, we gotta switch them out. So they're telling me to use V and D. I gotta change X and Y to V and D, but how do I know where they go? We'll come back to our graph here. This is normally our y-axis. What is our y-axis talking about? Well, our y-axis is talking about visits. That means instead of y, I'm going to use v for visits. Our x-axis, this number line here, is talking about days. So that means instead of x, I'm going to use d for days. Once you've done that, that makes switching them out really easy. I am going to say instead of y, let me use v. And instead of x, let me use d. So we get v equals 30d. Again, I think like a good check with these problems, but also some of the word problems we did in the past. So once you get an equation, try putting it back into words based on the situation. This is saying the number of visits, right? They just said v is the number of times the website's visited. So this is saying the number of times the website is visited equals 30 times the number of days, or 30 each day. Well, what I just said, the visits equals 30 each day, that's what we said in the first part with our slope. It's 30 each day. So this checks out, it aligns with all the other stuff we've said about this graph. So this right here would be our answer for the question, write an equation that represents this. There is one last part. That last part, let me clean all this up a little bit, sorry. That last part is the question. If this trend continues, how many times will this website be visited in 30 days? What they mean by that is if this trend continues, if this line keeps going on forever and ever and ever, how many times will the website be visited in 30 days? Go ahead and try that one. There are a lot of different ways you can figure this out. If I had given you a smaller number, like maybe 3 instead of 30, one way you could figure it out is with the graph. You could just find the number of days, so something smaller, maybe like 3, and then use the graph to answer the question. But this isn't asking about 3, this is asking about 30, and my graph is not big enough to see how many visits it gets after 30 days. It's one of the limitations of having graphs. Graphs are really nice because I love having a visual in math, but you can't show everything with a graph. Instead of using the graph, something you could use instead is our equation we wrote. Equations don't have a limitation. You can use any number, 30 days, 300 days, 3 million days. This equation will work for all of them. So I'm trying to figure out how many visits we get in 30 days. Well, when they say 30 days, they're just telling me make D equal to 30. So I could say V equals 30 times 30. 30 times 30. There's a trick you can do when numbers end with 0. 3 times 3 is 9. And then count your zeros. There's 1, 2 zeros. So 1, 2 zeros. I get V equals 900. Or to answer the question, how many times will it be visited? It'll be visited 900 times. There's one other way to get this answer, and it's not really using the equation, it's just using some of the stuff we said before. In that first part of this question, when I asked you what's the slope and what does it represent, we said the slope is 30, and it represents the website gets visited 30 times each day. You could just use 30 times each day and make yourself a multiplication problem. 30 times each day times 30 days means 900 times. It's the same thing we're doing here with the equation. It's the same type of math, but maybe just like a different way to think about it to get to that same answer. This is the last problem I had for you guys. Hopefully you're feeling more confident about applying linear equations to real world situations. I've said in previous lessons, but I love this lesson because I feel like it's connecting a lot of things. It's connecting all the stuff we've done with linear equations in this unit to real life stuff, which I always like you guys being able to see where we can use this math, but also going back to the word problems we've talked about too. We've written equations like this from word problems. So it's connecting a lot of different things in algebra and giving you an opportunity to see how it's all related. That is all I've got for you guys today. Thanks so much for watching. Bye.